All right, welcome to our lesson 6 in the study of polynomials. We're going to be looking at factoring some special types of polynomials, uh, two main types here that we're going to look at, and we're going to show what it means to solve polynomial equations. So let's go ahead and take a look at factoring a sum and or difference of cubes, or sum and difference of cubes, sum or difference of cubes. Really, we're looking at things that look like this, like the original statement here, 27x cubed plus 8, where we could say that 27x cubed is really 3x to the third power, and 8 is really the same thing as 2 to the third power. So this would be, because this is addition, the sum of two cubes, whereas the next example here is x cubed minus 216, and that could be x cubed minus 6 cubed, which would mean this would be a difference of cubes. And when you see problems like this, they factor very nicely into a very simple formula, one that you should try to put to memory as much as you possibly can. And the formula is this: when you have something cubed plus something cubed, we write it as a plus b. So I said a cubed plus b cubed. This becomes a plus b times this new quadratic, a squared minus a times b plus b squared. And the difference of cubes would be a cubed minus b cubed, can be factored to a minus b times the quadratic a squared plus a times b plus b squared. So what does that mean for our first cubic that we had up there, the 27x cubed plus 8? Well, we know that that is 3x cubed plus 2 cubed, which means our a, if you were to label this according to the letters that we're giving things here, we could call this a, and we could call this b. We have a cubed plus b cubed, so we could follow the first formula, if you want to call it a formula. So my a is 3x and my b is 2, so my first factor is 3x plus 2, and then we have to fill into the other piece. We want a squared, so we have 3x squared. Note my use of parentheses here, so you remember to square the 3 as well. You'll notice here at the bottom. Then we have a times b, so that's 3x times 2. And the last we have b squared, so that's going to be our 2 squared. All we do is simplify. We have 3x plus 2 times 9x squared minus 6x plus 4. Now, this is a very handy formula to know how to factor differences and sums of cubes, because we can use them to solve these types of equations. So I also have the other example we're going to look at as well. Looking at x cubed minus 216, we could write that as x cubed minus 6 cubed and use the second formula there. So we could say the second one being a difference or subtraction. We could still let the first thing be a, and the second thing is b. So then we get a minus b, so that's x minus 6, times a squared, so x squared, plus a times b, that's x times 6 is 6x, and a plus 6 squared, or b squared, and we simplify that down to the bottom line here. All right, so it's a good idea to know your cubes, your cubic numbers. If you need to look that up, you can, but the good first few cubic numbers that we need to know are 1, that's 1 cubed, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and usually those are the biggest the numbers get for us. They might go a little bit bigger, but you just need to determine if the numbers are cubes. So notice here 8, 27, and 216. I knew those were cubic numbers. All right, so what does that mean in the world of solving equations? So if I was to give you a statement like this, 27x cubed plus 1 is equal to 0. Well, we don't know a way of solving this outside of trying to factor. So we would factor it as we just did. In this case, 27x cubed is 3x to the third power, and 1 is 1 cubed. And through the process of factoring using that sum of cubes, we get 3x plus 1, so that's my a plus b, if you need those labels there. That's my a, and that's my b. So we have a plus b times a squared minus a times b plus b squared. Simplify that down to the product of two things equaling to 0. Now, this quadratic does not factor, but we know how to solve a quadratic that's not factorable. And one of the properties that we learned in the last chapter says that if we have two things multiplied together that equal 0, we can set them both equal to 0 separately. So we could say that 3x plus 1 equals 0, and we could say, not sure why that keeps doing that, we could say 9x squared minus 3x plus 1 is equal to 0. So the first one is very easy. We're going to subtract 1, and we're going to get 3x is equal to negative 1, and we're going to divide by 3. So we get x is equal to negative 1/3. The second one is a non-factorable quadratic, which means we need to use the quadratic formula. So it's going to be x equals the opposite of b, so positive 3, plus or minus the square root of b squared, so I'm going to write that down in here, negative 3 squared minus 4 times a, which is 9, times c, which is 1, all divided by 2 times a, which is 9. Simplify that down, we get 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 9, which is 36, all over 18. Notice we get 9 minus 36. That means it is a complex number because it's negative under the square root. So we get 3 plus or minus the square root of negative 27 over 18. What I'm going to remember is that 27 is equal to 9 times 3, and actually negative 27 is 9 times 3 times a negative 1. So if I'm taking the square root of that, that means I'm taking the square root of that. The square root of the square root of 9 is 3. The square root of negative 1 is I, and the square root of 3 has to stay under. So we can simplify this to 3 plus or minus 3i, radical 3, all over 18. And then we remember that we can, if all three of these things divide evenly by the same number, we can simplify. So this goes into, 3 goes into that once, 3 goes into that once, and 3 goes out into that 6 times. So we get a final answer of x equals negative 1/3 and x equals 1 plus or minus 1i root 3 all over 6. And we get 3 answers, and it is what kind of we should expect because it's a cubic. And so there you have it. We're going to we're going to solve using the factoring, but still remembering how to use the quadratic formula on non-factorable quadratics. All right, what's next? We're going to look at how to factor a quadratic type polynomial. And what that is it's basically an even degree polynomial that acts like a quadratic. This is an example. X to the fourth minus 2x squared minus 8. What you need to notice is the first exponent, the biggest exponent is even, and the second exponent is half of that bigger exponent. So 2 is half of 4. And when you see that, you can pretend that that is like a quadratic, x squared minus 2x minus 8. So if we tried to factor that, we would say, okay, what two numbers multiply together to get negative 8 that will add together to get negative 2? And we know that to be minus 4 and positive 2. So we would factor it to x minus 4 and x plus 2. But that's the quadratic. So this is x to the fourth minus x squared minus 8, but it pretends to be a quadratic, so it kind of acts like a quadratic. So we can factor it in the same manner. The two numbers to multiply together to get negative 8 that will add together to get negative 2 are negative 4 and 2. So we can write it, instead of x minus 4 and x plus 2, we can write it as x squared minus 4 and x squared plus 2. So then if we were to ask, well, what if we wanted to set it equal to 0 and solve? So we would look at this. We would note that it is like a quadratic because it's a 4 and a 2. It could be a 6 and a 3 or an 8 and a 4. They're all the same type of problem. We would factor that quartic, and we would set both of those pieces equal to 0 like we did a moment ago. So we would say x squared minus 4 equals 0, and x squared plus 2 is equal to 0. So the next part here is easy to solve. We'd say, okay, we'll add 4 to both sides. We get x squared is equal to 4. And we would take the square root. We would note that x is equal to plus and minus 2. Because when you take the square root, you have to have plus and minus. Likewise, on the other piece, we would say x squared plus 2 equals 0, so we would subtract 2 from both sides. When we take the square root, we would get the square root of negative 2, but the negatives under the radical means the imaginary number I, and be left with I root 2 and negative I root 2. And you need to notice that there are 4 different answers, or 4 total answers here. And that, again, is what we kind of expect with an x to the fourth polynomial. That is actually all that we had for this particular lesson. Factoring quadratic type polynomials and factoring a sum and difference of cubes, and using those factorings to solve some simple polynomial equations. So you'll notice there down at the bottom, I covered up the next lesson statement, but the next lesson is our lesson 6. It's going to be looking at some of the root theorems for polynomials. I'm going to leave you at that, and I will see you guys tomorrow.